Students, in this video, we will continue the classroom discussion, and I will introduce what are the end of the chapter's important terms and ideas. In my estimation, this gives you a good summary of what you are to expect in the chapter. And what I want you to note in this, that there is a set of bold-faced terms. Some are single words, some are multiple words. And you should learn these terms. You should review them often until they become innate to you. The first listed here is the scientific method, and it's the method of studying nature. Has 4 steps: formulating a problem, observation and experiment, interpreting the results, and testing the interpretation by further observation and experiments. You find that the scientific method is not an absolute all-knowing uh, process. It is the method of continual development of reliable information. That's all it is. It's not just a collection of facts and figures, although it may seem that way. It seems that way sometimes when your teacher present the material as if everything is all knowing and all known, but that is not the case. It is a constant process of collecting data, um, performing experiments over and over again, and retesting to get within a statistical result of what you already generated. So the very first proposed, a scientific interpretation, is called a hypothesis. After thorough checking, it becomes a law if it states a regularity or relationship, or theory if it uses general consideration to account for specific phenomena. The next boldface word is Polaris, and it is the North Star. It's truly called the North Star, and it lies almost directly above the North Pole, the North geographical pole. And you will find, as we consider this information further, that this star appears to move less than any other object in the sky. Obviously, the moon moves greatly. The sun has the appearance of moving greatly. And stars at night, some appears to move, but you will find that this star does not move much at all. What is a constellation? It is a group of stars that form a pattern in the sky. And you will find that many stars that form this pattern, some are near, some are extremely far, but relatively speaking, when you see them in the sky at night, of course, they have a regularity that we call a constellation. The planets are heavenly bodies that shift their position regularly with respect to the stars. The next word is this Ptolemaic system. The P is somewhat silent, but it is an antiquated system that is no longer true, and it had that the earth is stationary and at the center of the universe. But that system, that idea is wrong, and now the Ptolemaic system has been replaced by this next Italian word, a bold-faced word, the Copernican system. And it has that the earth rotates on its axis. It spins around 24 hours per cycle, with the other planets revolving around the sun. So the Earth is effectively one planet among several other, and all of them revolve around a star that we call our sun. Observation evidence supports the Copernicus system. Now, this guy called Kepler has three laws, and they are a regular. There are three laws that talk about regularity that planets observe as they move around the sun. Then Newton laws of gravity describes the attraction of all mass bodies in the universe have for one another. The gravitational force the sun exerts on the planets are what holds them in their orbit around the sun. Kepler laws are explained by the law of gravity. Now we talk about tides, and you will find that at at every point on the Earth's surface, there's nearly two high tides and two low tides per day. We will then talk about units in physics and in this part of physical science, and nearly every quantity we talk about will have units. And the unit of time is the second. The unit of length is the meter. The unit of mass is the kilogram. And this will be called the metric system. We will talk about conversion factors because any length given in one unit of measurement can be changed to another unit of measurement as well. And lastly, we will talk about significant figures and learn about those. These will come in measurement processes and how accurate are each digit that's a part of the number. So that's the process that we will go through. And so all is well as we go through that. So this comes to the end of this uh, presentation, okay?